everyone. Good to see you. I hope you had a great day. And let's start. So today I'm going to talk about design system and Jetpack Compose. And I'm working at Bumble, and Bumble is a parent company that operates couple apps, Badoo and Bumble. It is a two largest world dating application with millions of users worldwide. And our mission is to build most equitable and inclusive and empowering ways to connect. And a bit more about the tech side of those applications. We have around 1 million lines of code in our project and around 5,000 UI tests. And speaking of the design system, of course, we have around 100 customized UI components in our design system. So we have a pretty huge project in our hands. And today we are going to talk about how we are going to implement our design system in Jetpack Compose, how to integrate it with existing Android views, how to test it, and how to integrate it with the business logic. So let's go to the Jetpack Compose part. What is a Jetpack Compose? It's a declarative UI framework for Kotlin. You may already have heard about it before, and it's really cool because it allows us to develop UI much faster and write less code. Let's take a look at the simple example of it. Here we have a super simple view where we have a couple text fields and a button. And we have a column. It's a composable functions, which is almost the same as a vertical linear layout in Android. Couple text functions, which draws the text on the screen. And the last one is a button which handles clicks and shows the text inside of it. And why are we really interested in adopting Compose in our project? We believe that it's going to be future of Android UI in a couple of years, and I hope maybe in 1 year. And we think that it allows us to develop applications much faster without having to write boilerplate and hacks around custom views and reuse a lot of components together. And Jetpack Compose and its unidirectional data approach easily integrates with our architectures that we use in our apps called MVI, Model View Intent. And another super cool thing that we already have our own declarative UI framework, which is based on Android views. So our developers in Bumble, they're used to writing declarative UI code, and adopting Jetpack Compose and learning the details of this framework shouldn't take much time because it's going to be the same paradigm that we already use. And of course, it is super easy to implement the design systems in Jetpack Compose, and we're going to take a look at today. So for us, the goal is to use Compose once the release is stable, but currently it is in the alpha. And I think they will announce the beta today, maybe in a couple hours. And before adopting it in production, we have to answer a couple questions. We have to create a design system, integrate it with the UI. Of course, we want to make sure that quality is up to our standards, so we have to test it and integrate with the business logic. So let's start with the design system. What is a design system after all? It's a set of rules and tools for UI design, which is defined for some scope, in this case, for our applications. And it usually consists of the text styles, of course. And another thing is the design tokens. Design tokens is basically a way to configure the design system. And usually those values are colors and dimensions. And those design tokens are used to define the parameters of the components and different screens that are used in the applications. And they are defined in the central place for the whole platforms. For example, we have design tokens defined for the design system, and they are generated for both Android, iOS, and web interfaces. So the values are the same and the appearance is the same too. The next one, of course, is the icons. And another one is the components. Basically, it's the Android views that we use and that are custom to our application UI. And the last one is a pattern. It's a common use cases for groups of components that are used all around our applications. And let's start with some example. So in our applications, it's a dating. So people like each other and they match. And currently we are looking at the match screen. It shows when people like each other. And the goal for us is to build such a design system, which is going to be allowing us to reuse the same code written in Jetpack Compose, of course, to be reused in both of our applications, Badu and Bumble. But the difference would be the configuration of the design system, basically the design tokens. And they should appear differently, but in code, it should be the same. So let's take a look in more detailed view at the screen. So on top of it, we have a component called match photos, basically two photos of a user and an icon beneath them. Then we have a couple different text fields with different text styles, header one and paragraph one. And on the bottom, we have a white button with a solid color. And they are grouped into the generic container called CTA box. So let's start with the text. If you are Android developer for a couple of years already, I believe you might have struggled with the text on Android, with the text styles, text appearances, configuration parameters, etc. And because Jetpack Compose is written in Kotlin, it is much easier for us to configure text. We have only one place to configure it, actually. It's a data class called textstyle provided by the framework. It has a lot of parameters, but we would need only a couple of them for our text style. So to define it, we have a font family called default, which is taken from the system settings. Another one is the font weight, and we set the font size and the line height using SP values. And of course, we have more than one text styles in our design system. So to configure them in one place, we create a data class called Typography and have the text styles as a field of this class. Let's move on to the design tokens. It is super simple for them. So for the colors, we can either extract them from resources using color resource function or create an instance of a color. The same goes as we did for the text styles. We group the colors into the data class called palette. Then we use the dimensions. Same case here with the colors. Extract them from the resources using dimension resource function or create an instance. But in this case, we're using the extension property called .dp, which inside creates an instance of a color. And yeah, another benefit of using Kotlin for this framework. And the same as we did with colors, we group them into the data class. And the situation with the icons is a bit different because in Android, we used to have only one class, drawable, which was drawing vector icons and usual PNGs, for example. But Jetpack Compose team decided to split it up, and now we have bitmap and vector. And to retrieve them from the resources, we can use image resource, which is going to be retrieving the bitmap value, and vector resource, which is going to be retrieving some icon in SVG or Android vector drawable format. But another benefit of using Kotlin as your primary framework, you can actually define the icon in the code. So in this case, we draw in some icon and draw in some paths right in the Kotlin code using DSL. And it may be useful to configure some dynamic icons with different behavior. And because it is usual Kotlin code, you can write ifs and any statements that you want while drawing this. So we have dealt with the design tokens and the text styles. So now we have to define a way for us to use them. And this way would be a theme, the common place where we define everything for our design system. But before we discuss the theme, let's discuss a thing called composition locals. Imagine that we want to draw a heart in some place of our application, and we want to configure the color of this heart on the application level. And if it will be the usual implementation, in the Jetpack Compose, we just have a function which draws something on the screen. And if you want to pass it all around our application, it would be an explicit parameter all around the hierarchy of our UI. And it would actually be a pretty bad implementation with a lot of boilerplate in the code. So to avoid it, Jetpack Compose provides a way to access some globally defined value for your UI hierarchy without explicitly passing it as a parameter to your composable function. And they are called composition locals. And to use composition local, we have to create a static instance of it using a function called composition local of some type. In this case, it's a color. And we name it as local hard color. And then in our UI, somewhere in the composable hierarchy, we use providers function, which actually defines and sets a value for this composition local. And then inside of the lambda we pass to this provider function, in the subtree of this, we can actually access this value using local hard color.current. And I like to think about composition locals as a hash map or service locator pattern. So basically we have a key and we have a value defined, and we can retrieve this value using a key. And all of this is attached to the view composition hierarchy of the Jetpack Compose. And of course, besides the custom ones, which we can define ourselves, the framework provides the default ones. For example, we have one for the context, for the lifecycle owner, and for the screen dimensions. And let's apply this pattern for our design tokens. So let's start with the typography. We create a key, local typography, and then we use some pretty neat trick, of course, with the help of Kotlin. So basically, we want to wrap up the invocation of local typography.current to make it less verbose. And using this composable property with getter, we can actually make it more beautiful by calling textiles.h1 instead of local typography.currents.h1. And the same as we did for the textiles and typography, we do for the colors and dimensions. And then we create a composable function called team. It is actually the place on the top of our application hierarchy where we configure our design system. And we pass the configuration, textiles, colors, dimensions, and configure them using provider function. And the last parameter would be the content lambda. Basically, it's a composable function where we can draw anything. In this case, it's going to be the actual UI of our application. And inside of it, we can access the values of those composition locals and access the configuration of our design system. And that would be it for the composition locals. But a bit like a small disclaimer, composition local is not a DI framework, so it may seem convenient to use it to pass in some dependencies to your composable functions, but please try to avoid it because composition locals allow to redefine the value in any place of the type tree. You can invoke providers function and use any key. So it could be hard sometimes to manage your dependencies using this way. So please, if you have a dependency like business logic dependency for your composable function, pass it explicitly as a parameter. Do not use composition locals for this. So we are done with the design system, team definition, and tokens. And let's move on to the components. So we have dealt with the text, and we have a couple components left. The first one is match photos. And another one is a button. So we'll start with the button because it seems a bit simpler. And Jetpack Compose and material material team already provides us as the implementation of a button. And it looks like this. So we have a button function, which has an onClick parameter and the content. And the button itself is actually the background, this purple square, and the click handling logic. But what is inside of it, in this case, it's a text, is controlled only by us, the developers. And it has super cool flexibility, and it works good for material team because material design is used in millions of applications all around the world. And the ability to configure the contents of a button without extending the button class, like we have in Android, of 1,000 something lines of code, is super convenient. But it has its downsides. Because this API is so flexible, we can actually draw anything inside of a button. Even button inside of a button, inside of a button, and then the text. So for us, we don't need this flexibility because we know everything about our buttons. And we specify all the parameters and behaviors and the states in the specification of our design system. So passing this explicit parameter called content and allowing developers to draw anything inside of it would actually make our developers, the main users of design system implementation, think more about what is drawn there and spend more time to actually implementing the same patterns again and again and again. So for this case, we won't need to reuse the material button and we need to create our own. So in our design system, we have three types of button: field, stroke, and transparent. And each one of them can have either text or text and an icon. And you may have noticed that they are pretty similar. So let's take a look how we're going to implement it. The API of this function called button is going to be pretty simple. The primary parameters, the required ones, would be the onClick function because the buttons that cannot be clicked doesn't make any sense. And the next one is the text because we have to show the text always. Another parameter would be the color and the content color. And as you might have already noticed, we are using the values of our design system using colors.primary as the default value. And the last couple one would be icon, which is optional. And in this case, it's a null parameter by default. And the last one, if the button is enabled or not. And you may already have noticed that they're looking pretty similar. So for this, we want to reuse most of the code for our button because they have so much common things, so it doesn't make sense to actually copy paste the code for them. So to make it easier for us, we would create a super generic function, which is going to be available only for us, the developers of the design system, to make our job easier and reuse some code. And it's going to be super generic function with a lot of parameters which we can configure. And even in this case, you may have noticed that we are using the design system values from the tokens and local composition. So how is going to look the composable hierarchy of the field button, for example? So field button is going to be a public API available for the developers. And inside of it, it is going to actually invoke the button skeleton with the correct parameters for this type of a button. And inside of it would be a surface, which draws a background and handles clicks, and then row horizontal layout, where we can show icon and text the content of a button. So the surface, we invoke it, add and configure the shape of a button, border, content colors, make it clickable using modifier.clickable. And the last one, we set an alpha for the whole content of a button if it is disabled. Then we have a row with some alignment parameters. And inside of a row, we show an icon if it is required and passed as a parameter. If it's not, we don't show it at all. And if it is shown, we actually also draw a spacer between the text and an icon. And the last one would be a text itself. And of course, we are using the text style from the design system configuration for a button. It is called textstyle.action. And this is how the public API would look like. So basically, the button is a wrapper around the button skeleton. So we're done with the button, and let's move on to the match photos. Match photos is super simple component. We have two photos and an icon beneath them. And hierarchy would be vertical linear layout, and on top we have couple photos in horizontal layout next to each other, and on the bottom we have the badge, the vector image. And we draw the images in Compose using pretty self-explanatory image function, but it is a bit rotated. So we have a modifier called graphics layer where we pass the rotation and translation of the graphics layer. And then we apply the Z index. Basically, this modifier is responsible for which component is going to be drawn on top. Then we set a size and the shape for the photo. And the last one would be a border if it is actually required for this type of a component. And same we did for the left photo and the right photo, and we group them to the row. And the last one would be the same function called image, but we show the vector image using it and draw some elevation using shadow function. So the last one would be our pattern, the super generic layout called CTA box. A CTA box is a layout with the placeholders. It's reused in a lot of cases in our application. And compared to the button example, we would actually want it to be super flexible and have an ability to draw anything inside of those placeholders. So for this, we just pass a composable function and we can draw anything in it. And the layout itself would be a vertical layout column with some arrangement parameters. And then we invoke our parameters, composable functions, which are going to draw the content and apply the spacers between them for the media, header, content, and the buttons on the bottom. So we have implemented all the components. So let's take a look how we're going to actually implement a screen, match screen with them. We have a CTA box which draws the match photos on the media. Header is going to be a text with text style.h1. The content is going to be paragraph 1 text. And on the bottom, we have a button where we configure and redefine the default value for it. And we use white color, and the text is going to be black. And by using the design system tokens in the code and composition locals, by applying the different theme to the same screen, we would make it look different. So the code stays the same, but the appearance is different because the design system and theme configuration is different. In this case, we have a border on the photos in Bumble, and we don't have it in Badoo case. And text styles are a bit different. Maybe the spacings are different too. And the shape of a button is different. Before we had a round square button, and now we have a totally round button in Bumble. So we have done with the implementation of the design system. Let's take a look how we're going to integrate it into our application and work with the existing UI, maybe Android views. So how do Compose works with Android views? Imagine the case where we want to draw some Android view inside of a Jetpack Compose UI. Maybe you want to integrate some SDK from external provider which shows ads in your UI. And for this, we have a composable function called Android view. And the first parameter for it would be the view block. It passes from parameter to the context parameter to the lambda. And using this context, we actually create the Android view. In this case, it's a simple text view, which we apply some parameters and properties which are not relying on the state of our screen and should be the same on each view we create. In this case, it's a set on click listener. And another parameter for the Android view function would be the update lambda. And it passes as a parameter the view we have created in the previous view block. And it is invoked when we redraw the screen again. And we redraw the screen when the state of the screen changes. So we receive the view width that we created before. So we don't have to create it each time the screen is redrawn. So it is cached inside of a composition, and we only update the property of it. In this case, we show another text with different counter value. And it is working. So we are clicking on the compose text and the Android text, and the state is updated in all of them. Super convenient and useful. And what about the other way around? If you want to use Compose UI, maybe we have implemented some fancy animation or components in the Compose because it is just easier to do it in the new paradigm. And we still want to integrate it into part of some screen which is still written in the Android view style. And it is even easier. So basically, we have a view called Compose view, and we integrate it in our XML layout, assign an ID to it, everything as usual. Then we find it, and this Compose view has a function called setContent. And setContent function is like an entry point to the world of the Compose. And inside of it, you can actually invoke your composable function and draw anything you want. But small note is that it is only available in Kotlin because it uses a Kotlin compiler. So we have integrated it into our UI, so let's test it. And you may already have noticed that we haven't assigned any IDs to our composable functions. And usually when we test things in Android, we use IDs to find the views on the screen and check their properties or interact with them. But Compose has a solution for this problem, and it provides a way to find a view on the screen, actually the composable component. And the solution is the test tag modifier. And for the screens, I'd like to group them into the object, which stores all the test tags for the screen because it will be used both in the test code and in the UI code. And to actually execute the test, we have to use a compose rule. We create it using a function called createComposeRule, and then set content to it and draw the actual UI which we are going to test. And once we draw this UI, we interact with it also using the compose rule. And the syntaxes of it is actually pretty similar to the espresso, which we are already using for the Android use. We find the view. In this case, it's a composable node using using a method called onNode with tag, and then pass a test tag to it. Then we check that it is displayed, that text on it is send message, and then we click on this button. And actually, we can use Jetpack Compose test rules and espresso code in the same test. In this case, we are testing our hybrid UI for using espresso code and compose test rules. And actually, I heard from the compose team, they have said it somewhere, that someday they will provide the compatibility for the espresso and compose. I think it's going to be super awesome, but we'll have to wait for some time to actually see it. And the last but not the least type of the tests we do for our design system is the screenshot testing. I wouldn't say much about it. Besides that, there is a super cool library called Shot from Karumi, and we use it, and it already has an integration for the Jetpack Compose and Compose test rule. So you can use it for your screenshot tests. And the last part for us would be the integration with the business logic. And for us, it is super easy because most of our code is written using MVI pattern. And Jetpack Compose loves MVI because the thing that we have a feature or a state container where the state of the screen is stored. And each time something happens and the state is updated, we produce a new update for the Jetpack Compose and update the state of our screen. And then Jetpack Compose just redraws the screen hierarchy, which depends on the state. And actually, the compiler handles the diffing logic, so it would redraw only the composable functions for the parts of the state which have been changed, and the ones that were staying the same are not going to be redrawn. And the back to the feature, we send the observable of the UI events, and we change the state and then redraw the UI again. Something similar happens to the MVVM, which is also pretty popular, but we have a view model with couple sources of the live data, which is subscribed inside of the Compose view. We have a new state of the live data, redraw the screen, we interact with the screen, we call some methods of the view model. Super simple and easy. And for using Java or live data inside the Composable to subscribe and receive a state, they provide a function called subscribe as state and observe as state. And by using it, we subscribe to the channel and receive its value once it is updated. And the last one, which is not that popular right now, I think, but it used to be pretty popular, the MVP. The problem with MVP is that it would require some specific handling logic because presenter should call an instance of a view class, but there is no class. There is only composable functions, which is invoked by the framework, not by us. And we cannot call the methods of a composable function directly because there is no method to be called. So if you want to integrate your Compose screen with the MVP business logic, you would have to create a class called viewWrapper, which implements a presenter view interface. And every time presenter calls a method of a view, it would produce a new state for the Compose and redraw. But I wouldn't recommend to actually use Compose with MVP because the solution is pretty hacky and you should use it. You should not use it unless you really have to. So let's summarize what we have learned today. And let's get back to our initial questions. So we have learned how to create a design system with a Compose, components, tokens, composition locals, the theme, and the screen. We have learned how to integrate Compose code and the Android UI code. We learned how to test it, and we have taken a peek at the integration with the business logic. And what would be the next step for us? For us, in adoption of the Jetpack Compose, we want to continue adopting it by creating a bigger set of the main UI components, because for this presentation, we have implemented only a couple of them. Then we want to experiment with it because Compose is still in an alpha stage and it has some performance issue and maybe some other issues which we want to learn about using experiments. And once we are pretty sure about Compose, we would start to implement non-critical features, maybe. And once framework is stable and we are confident in it, we are going to ship it to production and deliver more value with the Compose. And if you want to learn more about our design system called Cosmos, my colleague has delivered a really good talk about it. Here's the link in the resources. And also Google has lots of cool tutorials for the Jetpack Compose, especially the Compose pathway is a really good one. And of course, we have a sample code on the GitHub if you want to check it out. And if you're interested in what we do as a Bumble in a company, like in the text perspective, we have a tech blog on Medium. Check it out. It has some super awesome articles about Kotlin internals, architecture, and all this kind of stuff. So I think we're done for today with this talk. So I'm open for your questions. Okay, let's take a look at the chat. Okay, we have a couple questions in the Q&A section. And the first one is from Narab. How would you enforce the correct usage of Compose code in a team? Do you have some kind of custom lint rules? We have custom lint rules for the existing code base, but we haven't written any of them for the Jetpack Compose yet. But Android Studio already provides some lint rules for the Compose, for example, for the naming guidelines. In this case, it would be, for example, for the composition locals, they actually force you to have a local prefix for them, or for the composable functions to be named from the camel case style, not the lowercase. Okay, the next one is from Julian. What is your strategy to introduce Compose in the large-scale app? As I said before, we want to take it step by step. Basically, the first step would be to experiment with it and make sure it is stable and works well with our infrastructure, because we have a huge infrastructure for building our applications, and we want to make sure that introducing Compose to it wouldn't break it. Because right now Compose is in an alpha stage and it still uses Preview Android Studio, Preview Gradle plugins, and Preview compiler. So we are not really confident to deliver code built with the Preview compiler into the prod. So we'll have to wait for the stable release to make sure it is safe to ship it in production. But now we are experimenting and checking out how the performance works for us on different types of devices, how this impacts our application size, and things like that. Okay, and another question is, what would you do for a different color of H1 text? For example, it should be green H1. It's a really good question, and actually the solution is super easy. So the default composable function called text accepts lots of parameters, and besides the text itself and the text style, it accepts a couple properties of the same text style, basically color, font size, and other properties. And if you would want to override one of them, basically first you pass the main text style, and then you pass as another parameter for the color, and it's going to be overriding the one defined in the text style originally. So basically, to answer your question, you would pass a parameter called color and make it green. And another question would be, is page navigations with animations, is it customizable? Yes, it is. So Compose doesn't have any fragments, and all you draw in your application UI is the code you write yourself. So to customize the transitions between the screen, you would actually write yourself these animations, but Compose frameworks provide the useful helper functions for this. For example, one of them is called crossfade, which implements the crossfade transition between the first composable function and the second one, different types of the screens you invoke inside of it. And by taking a look at the example of the crossfade implementation, you can actually implement your own one. Okay, another one is Does Compose work with constraint layout, or it has own approach about it? Compose has its own implementation of the constraint layout with a familiar API. It doesn't have the live preview editor as we have right now with the constraint layout for Android views. But I think that constraint layout is not actually that needed for Compose because I haven't used it ever during my experiments with it. And this is why the reason for it would be that in Compose, having a nested hierarchy is not a problem because compiler handles it for us and is actually encouraged by the framework to wrap composables inside each other. So it's not a big problem for us to wrap column inside a row, inside a column, inside a row. And it used to be a problem with Android views, but with Compose, it's not a big problem. And we don't have to actually use constraint layout for this case. But if you really want to, it is available. Okay. Until now, there were approaches like layout and layout large for tablets. Have you tried a different configuration with Compose and how it affects the code base? I haven't tried this, but to actually implement it, we have a way because we don't use the resources for the layouts anymore in Compose, but we have an ambient called density and screen configuration. It's like a global property which is going to be updated once something in the context is changed. And in this ambient, we have a parameter called is it a tablet or not, and screen density and screen size. And based on those parameters, we can actually invoke different composable functions and draw different layouts on screen. But supporting multiple of them could be problematic. Maybe you should have like a tablet UI and phone UI as a totally different like modules in your project. And in the root of your view hierarchy or composable hierarchy, you would check if it's a tablet UI, you just invoke the whole different thing, tablet UI. And if it's a phone, you invoke a phone. And between them, you reuse the components, maybe some shared parts, but fundamentally on the root level, they would be different. Okay, the next question would be have you used subcompose layout or previously measure with constraint? Any chance for tips on how to use it correctly? Unfortunately, I haven't been playing this much with layouts in Compose, so yep, I haven't used subcompose layout yet. And yep, I think we are done with the questions. So thank you all.